Hello all. In previous session, we have seen classful addressing where we have seen five classes: class A, B, C, D, and E. We have also seen IP version 4 address, so 2 raised to power 32-bit address space is there, right? So which support more than 4 billion of different devices using IP version 4 addresses, right? In today's session, we'll be discussing about the CIDR notation, which is also called as CIDR or slash notation. Okay, and from those slash notations used to indicate the IP addresses, how to identify number of addresses used, right? Then the first address and the last address, and how to identify these three different values from the given CIDR address. Okay, so basically, as we discussed in the previous session, as there are different classes. Okay, so in case of classful addressing, today we'll be discussing about classless addressing, right? So why there is need of classless addressing? So classless addressing is the extension of this classful addressing. So if I'm talking about class A address, as we have seen in the previous session, so it was total 32-bit address. 32 bits of address is divided into 8 bits as the network address, right? While the 24 bits for host addresses, right? Or the node addresses. So if I'm talking about class A, so out of these 8 bit, first bit is always 0. So it is supporting only 128 networks. Okay, so 0 to 127 can be the value of first 8 bits in case of class A addressing, as we have seen in the previous session, right? So that means there will can be total 128 networks, right? But in each network there can be 2 raised to power 24 host. So if you compute this particular value, that is 2 raised to power 24, so if I'm talking about this value, so it comes around that is 16777 okay, so it is 1,67 lakhs 77,216. Okay, so in single network there can be these many hosts, more than 1 crore of host, 1.5 crore or 1.6 crore of host, right? So if I am giving any class A address to a single organization, right? So a single organization can have these many PCs, but in the real scenario, it may happen that a single organization will not be using these many addresses for their host. So some of the addresses will be unused, or these addresses will get waste, right? In case of classful addressing. Okay. So this concept is called as address depletion. That is nothing but the reduction in the available address space, IP address space, right? So if single IP address is assigned to a single organization, so some of the addresses will be unused. But when I look at the class C address, right? So first 24 bits are used for network address, and the last 8 bits, only 8 bits are used for host address, right? So only 256 hosts can be there in a single network, and total networks can be 2 raised to power 24. So again, it because the first 3 bits in case of class C are always 110, right? So it comes around again up to 1 crore or more than 1 crore of networks will be there, but each network will be only comprising 256 hosts. But if organization has a requirement of more than 256 hosts, so I have to give more class C addresses to that host, right? So To avoid these problems, there is concept of subnetting and supernetting. So subnetting is applicable to class A and class B, while supernetting is basically applicable to class C. So in case of subnetting, instead of giving this single address or a particular IP address from class A, which will support more than 1.6 crore of PCs, will be dividing these 1.6 crore of addresses into sub networks. So single network will be divided into sub networks, so which is called as subnetting. So this can be done in class A and class B. But in case of class C, only 256 hosts are there, so we'll be clubbing more addresses so that more number of hosts should get supported. So it is called as what? Supernetting. Okay. In subnetting, we are dividing network, while in case of supernetting, we are clubbing or combining the networks. So from there, this concept of slash notation comes into existence with the increase of internet service providers, right? So internet authority has devised this new notation of representing IP version 4 addresses, which is called as slash notation. Okay, so slash notation formally as classless interdomain, which is also called as what? Classless interdomain routing, referred as CIDR and pronounced as CIDR notations, right? So it is classless interdomain routing. So here this example is there, right? You can see here 8-bit combinations are exist there, that is 1 byte, 1 byte, 1 byte, 1 byte. Okay, so total 32-bit address is there, but along with that this additional information has been sent, that is slash n. As here you can see example, first one is 12.24.76.8/8, right? So the instead of specifying the complete address, so block of addresses has been assigned, and that block is indicated by 8/8, right? So total addresses available in this particular network having such IP address will be simply 2 raised to power 32 minus 8, right? So these many addresses can be there. Okay, so that is how this notation is used. So let's say example so that this can be more clear. So from these CIDR notation addresses, right, you can extract these three kind of information. First one, how many total addresses are there and what will be the first address and last address in that network. So number of addresses, the first address in the block and the last address in the block can be identified, right? Correct. So the number of addresses in the block can be simply identified by 2 raised to power 32 minus n, as I have just indicated here, that is 2 raised to power 32 minus 8, because the value of n here was 8, right, in the slash notation. Then you can also identify the first address. How to identify that first address? So whatever address has been given there, so we'll convert this address into binary notation, and then we'll keep the first small n bits as it is, okay, and the remaining 32 minus n bits will make it as 0 to get the first address, right? And to get the last address, again we'll keep the first n bits as it is. In previous case the value of n was 8, so 8 bits will be kept as it is, and remaining 32 minus n bits will be made as ones. Okay, so this is how it has been indicated here. So any address has been given, so n bit prefix and 32 minus n bits will be the suffix. So to get the first address, what we have done, we have kept n bits as it is, right? And the remaining all bits will be change it to zeros, right, to get the first address. And to get the last address, we keep again n bits as it is, and the remaining 32 minus n bits will be changed to 1. the number of address will be simply 2 raised to power 32 minus n will be there, right? So let's see example here. Instead of just discussing this example, so just discuss it. Okay, so here as the value of n is 27, so total addresses in this particular block of addresses will be 2 raised to power 32 minus n. So it will be 2 raised to power 32 minus 27, so it will be 2 raised to power 5. So 32 addresses will be there. The address, if you convert it into binary, so 167 will be represented at this value, right? Then 199 is there, 170 is there, and 82 is there. How this is converted to binary was seen in the previous session, right? To get the first address, so we'll be keeping first 27 bits as it is, and we'll be making these last 5 bits zeros. Okay, so that has been indicated here. So first 27 bits has been kept as it is, while last 5 bits has been changed to 0. And if you calculate this value, so this is nothing but again 167, this is 199, this is 170, and this is 64, right? Slash 27 has been added. So to get the last address, again we'll keep first 27 bits as it is, right? And we'll make this last 5 bits as 1. So this has been indicated here to get the last address. So here it should be last address, not the first address. Okay, so fine. So let's see example here. We can take this address 12.24.76 slash 8, 12.2476 12 dot 24 dot, what was there, 12 dot 247688. Okay, one more example is there, so let's try to solve it initially. 76.8 slash 8. Okay, so total number of addresses in this block will be simply, it will be 2 raised to power 32 minus small n, so small n value is 8 here, so 2 raised to power 32 minus 8, so 2 raised to power 24 will be there. And the value of this 2 raised to power 24, so total addresses will be 167.216 216 will be there. Okay, so I'll write here 16.7.216 will be there. Okay, to identify the first address, initially we'll just represent this address in binary. So 12 can be represented as 4 zeros, then 8 plus 4 will be 12. Okay, so address in binary notation. Okay, then 24 I can represent it as 0 0 0, that is 16 plus 8 will be 24, right? Then 76, to represent 76, it will be 64 plus 8 plus 4 can be 76. Okay, so to represent 76, I'll make first bit as 0, right? Then here 1, that is 64, then 0 0, then 8 will be 1, then 4 will be 1, and then 0 0. That is 64 plus 8 plus 4. Okay, that will be 76. Right. Next 8, for 8 again I will be taking this bit as 1 and the remaining bits as 0. Okay, so this is actual binary notation representation for the given IP address. Now to find the first address in the given address space, what I have to do, I have to keep the first 8 bit as it is, and the remaining all bits will be changed to 0. Correct? So as you can see here, I will be keeping the 27 bits as it is, and last 5 bits I have changed to zeros, right? So here I have to keep first 8 bit as it is, and the remaining 24 bit I will make it as 0 to get the first address. So 0 0 0 0 1100, right? And remaining all bits I'll make it as 0, remaining 24 bits, right? So here IP address will be, the first IP address will be simply, this is 12, 8 plus 4 12 dot 0 dot 0 dot 0 slash 8 will be the first address. And what will be the last address? So for last address, again I will keep the first 8 bits as it is, and remaining 24 bits, right, I will change it as 1. Okay, so that will be the last address. Correct? So the last address will be 12.255.255.255 slash 8 will be the last address. So this is how you can identify the total number of addresses supported, the first address and the last address in that range. Okay, so if you calculate from this first address to this last address, so you will get total these many addresses. Correct? So now let's see the Python code to extract this information from the given slash notation or the CIDR address. Correct? So as I already told you that to eliminate the disadvantages of classful addressing, okay, so subnetting and supernetting has been used. So instead of assigning the exact IP address, so block of addresses will be assigned to the organization. So if I'm considering this particular block, if I'm assigning this block to the organization, so it will be supporting to rest about 24 different addresses, okay, which will be starting from a given address. The example which has been shown in the previous slide, so if I am assigning this particular block to the organization, so only 32 addresses are assigned to that organization, not all the addresses in that particular given addresses. If we are not using slash 27, so all the addresses fall in that particular category will be, or class will be assigned to the organization. Now let's see the Python code here, right? So I have already opened the Anaconda prompt and the Python code. Okay, so just a minute. Okay, so here the Python code is there. So again, as in previous example or Python code where users use this IP address. Okay, now first statement in this code is enter CIDR address, right? So whatever address will be entered by the user, that will be read by the input function and it will be assigned to IP. So I have already opened the Anaconda prompt here. So here I have saved this code inside CIDR directory. Okay, so I'll initially switch to that drive and I'll move inside that directory. Okay, and I'll simply execute it as Python CIDR. Okay, so here you will get this message as indicated, enter CIDR address. This is the commented line. Okay, so instead of taking it from Anaconda prompt, you can also directly specify it inside this particular. Okay, So we'll be checking this IP version 4 network address that will be passed to this IPv4. This IPv4 network is from IP address library, correct? And it will be assigned to n, and directly you can extract the first address and last address as the first element in that n and n minus 2 element in the last address. Okay, and to get the total number of addresses in that particular block, so what we have done, we have split that address, so using slash notation. So the CIDR of 0, CIDR of 0 will be comprising this value, and CIDR of 1 will be comprising 17 if I am entering that address, right? Here that value has been printed, so simply these two values will be separately printed here to get the total uh, length of address. So I have simply done here 32 minus integer of CIDR of 1. So in this case it will be 32 minus 17, correct? Because CIDR of 1 will be comprising value 17, correct? So those many bits will be there, that is 32 minus 17, so 15 bits will be there. So the value of ADDR will be 15. So I will be taking it as power of 2 comma 15 here, so 2 raised to power 15 will be there, right? So if I'm doing it as 2 raised to the power 15, so it will be 32768. So total addresses supported here or total host will be 32768, and first and last address has been printed here. So it is very simple code. We are not defined our function, we are using all predefined functions to get the information, right? Okay, so let's try to execute it. So here you can simply enter, just for example, 10.10.128.0/17. Okay, so that information has been indicated, correct? So here you can see the IP address that I have entered using this split. Okay, I have separated uh, the IP address and this slash value. Okay, so after separating it, I have calculated total host. So 32768 hosts are there. This is the first address and this is the last address, right? The example that we have solved, just will try to verify it if it is the correct IP address we have specified. We are not also verifying the IP address here. Okay, so we have seen in previous session how IP address can be verified, whether it is correct or not. Okay, so if it is a correct IP address, so what is that? 12.24.76.8/8. So if it's correct IP address, then it will obviously indicate this information. Okay, so as you can see that it is not the correct IP address, so therefore it has thrown an error, correct? So again, if I am executing it, I can specify, just for example, if I am modifying this CIDR value, so you will get separate values here, right? So you can also observe there, now the total number of hosts has been reduced, right? 2 raised to power 12, 4096, start address and end address has been changed, as it can be observed from here. Okay, so start address was same, but end address, last address was different, correct? So you can again verify it, but the correct IP address should be specified. So this was not the correct IP address that was specified. You can also try for this one, whether it is the actual correct notation for the CIDR address or not. 167.199.170.82/27, just for example. Again, it is not the correct notation, right? Okay, fine. So this is how you can verify the CIDR address. Okay, so I also explained the code here. Correct. So fine here. So that's all for today's session. Right. So thank you for joining.